Hello everyone. Today we will talk about Chapter 8, Correlation and Regression. First of all, in this chapter, there is scatter diagram. You must know 4 types of scatter diagram, which are negative nonlinear, positive linear, negative linear, and no relation. The scatter diagram is a graphical technique used to show the relationship between variables. Next is covariance. Covariance is a measure on how much the variables of x and y vary together. And the formula of covariance is defined as the summation, the formula for covariance is the summation of x minus mean of x multiplied by y minus mean of y divided by n minus 1. We also can say it SSSY over n minus 1, where SSSY is the summation of xy minus summation of x multiplied by summation of y divided by n. Let's take a look at the example. For this question, to find the covariance, first of all, we must find the mean of x. So, based on this table, there is 8 elements. To get the mean of x, we must add all the x value and divide it by 8 to get the mean, which is 10.25. And it is also the same for mean of y. We will get 20.5. Then the value of x must be subtract with mean of x to get the value for this column. And also for this column, we must minus mean of y from the value of y. So, to get the value for x minus mean of x multiplied with y minus mean of y, we multiply the value of this column with this column to get the value for each of them. So, to get the covariance, as we use the normal equation, which is SSSY divided by n minus y. SSSY is the multiplication of x minus mean of x and y multiplied with y minus mean of y divided by n minus 1. So, the total of multiplication between x minus mean of x and y minus mean of y is negative 16, and x minus 1 is equal to 7. And we got our covariance is negative 2.2857, which are negative covariance. Next is coefficient of linear correlation, or defined as R. So the equation for R is equal to covariance of S prime Y prime equal to covariance of X Y divided by SX and SY. So, to be concluded, R is equal to SSSY divided by square root of SSX and SSY. So, what is SSX, SSY, and SSXY? So, SSXY is summation of xy minus by multiplication of summation of x and summation of y divided by n. For SSX is equal to summation of x square minus square of summation of x divided by n, while SSY is summation of y square minus square of summation of y divided by n. So there is 3 types of correlation coefficient value. The first one is perfect positive correlation. Second one is perfect negative correlation, and the third one is a coefficient of 0, which is no describable relationship between fluctuation of variables. So let's take a look at the example. To find the Pearson product moment correlation coefficient R for this question, using the equation given, we must find SSSY, SSX, and SSY. So first of all, we must find the summation of X, which is 108, and the summation of Y is 231. Next, we must find the summation of X squared, Y squared, and XY. We got the summation of X squared is equal to 1500, summation of Y squared equal to 8799, and summation of XY we got 2830. So to calculate SSXY, we use the equation as I said just now. So we got negative 288.5. For SSX, use the equation and we will get 42. And it is the same for SSY, we will get 2128.875. As we got all the value for SSXY, SSX, and SSY, we can calculate the value of R. So we just use the value that we got just now in the equation, and we will get the value of R is equal to negative 0.9648. So next is regression analysis. So first, you must know simple linear regression. So the equation of the regression model is given by y equal to b0 plus b1x plus e, where b0 is referred to y-intercept, b1 is referred to the slope, and e is referred to experimental error. And e is the difference between observed value of y and predicted value of y at a given x. So, the sum of residual is exactly to 0, and the mean value of experimental error is 0. Variance of experimental error is denoted by this. So, we estimate the regression model using sample data. By the method of least square, we obtain the estimates of B1 and B0. So, to get B1 value, we will use SSXY divided by SSX, while B0 is equal to mean of y minus B1 multiplied with mean of x, which is also equal to summation of y minus b1 multiplied with summation of s divided by n. So, the line of best fit or the estimate regression is defined as y hat equal to b0 plus b1 multiplied with x, or observed value y is equal to b0 plus b1 x plus e. You must be noted that a scatter diagram may suggest curvilinear regression, and if two or more input variables are used, it is called multiple regression. Next is experimental error. Experimental error is error that may occur in the execution of a statistical experimental design. Types of experimental error include human error or mistakes in data entry, such as systematic error or mistake in the design of the experiment itself, or random error caused by environmental condition or other unpredictable factors. Experiment design seeks to minimize experimental error in order to produce the most accurate data possible. So, the formula for variance of experimental error, or as known as S E squared, is equal to the summation of square of y minus y hat divided with n minus 2. Or to make it easy to understand, we use summation of y squared minus with b naught multiply with summation of y minus with b1 multiply with summation of sy divided with n minus 2. Or we can say it summation of square of error divided with n minus 2. So let's take a look at the example. A recent study was conducted to determine the relation between advertising expenditures and sales of statistic text. The data is given below. Find the line of the best fit and the variance of y about the line best fit. So, first of all, we must find the summation of x, which is 459. Next, we must find the summation of x squared, which is 21,677. Next, we must find the summation of y, which is 3,699, and the summation of xy is equal to 174,163. So, to calculate the line of the best fit and the variance, we must get our SSX, SSXY. So, using the earlier equation, we will get the value for SSX is equal to 608.9, and also SSXY using the earlier equation, we will get 4,378.9. So, as we got the value of SSX and SSXY, we can calculate the value of B1, which is 7.1915. And the value for B0, we use the equation summation of y minus with B1 multiplied with summation of x divided by n. We will get 39.8105. So, the equation for the line of best fit, as we all know, y hat equal to b0 plus b1x. So the equation for the line of best fit is